Okay, so in your packets, go ahead and open them up to the part that says 9.5. And take a minute and go ahead and graph sine of x again. This is actually very important. Nope, just start. We collected. Oh, but you turned it in already, right?
Yeah.
Okay. This is 9.5. Yep, we're in the packet. If you've done it correctly, which I can't imagine why you wouldn't at this point, it should look roughly something like that. Okay. Do you guys remember what 1-to-1 meant? Very good. It passes both vertical line tests, which this certainly does. However, it does not pass horizontal line tests. So we say this is not 1-to-1. And for that reason, the way this is graphed currently, the inverse will not be a function either, which presents a problem for us. Okay? But what we're going to do is chop up the sine graph so that we hit every possible output that we need. So you know how we're always between -1 and 1, right? Well, from where to where would be a good piece of the graph that's between -1 and 1? There we go. This little box, the rectangle right here. This is as small a window as we need because if you look carefully in this little rectangle, the function goes through all the outputs of the sine graph. Okay? This part of the sine graph is called the restricted sine graph, the restricted sine function. So I'm going to very carefully draw just this part of the sine graph because you're going to have to know a lot of details about it. So we're going to go to pi over 2. We're going to stop at -pi over 2 in the negative direction, and we're between 1 and -1. And now at 0 we're at 0, at pi over 2 we're at 1, at -pi over 2 we're at -1. Now it's not a straight line, because you know that it's a curvy graph, right? And the shape here is very important. As it reaches 1, what does the sine graph start to do? It starts to turn around and decrease, right? So it should look something like that and something like this. It's kind of like a cubic graph, yeah, but just part of it. You don't want to go the other way if you curve it this way, because then that would mean that it's increasing, right? That it's getting steeper at 1, which we know is impossible because it needs to come back down. Okay? All right, so according to this picture, what's the domain? Negative pi over 2 to pi over 2. And what's the range? Negative 1 to 1. Yes?
Why is negative negative infinity, or is it just for this?
Just for this restricted picture. Yep. So we're not talking the original sine function, just this little window of it. All right. Now, a while back, you guys learned that even if you don't know what, I mean, we already know the inverse function. It's y equals inverse sine. Even if you don't know how to graph it per se, if you have this picture, how do you graph the picture? Yeah. So let's just do that real quick. So now instead of x going from negative pi over 2 to pi over 2, x will go from negative 1 to 1, and then y is between negative and positive pi over 2. And negative pi over 2 comma negative 1 becomes negative 1 comma negative pi over 2. So it actually looks like it's in the same spot, sort of, right? Different x and y values, but graph, I mean, if you look at the picture, it's pretty much in the same position. 0, 0 goes to 0, 0. And then positive pi over 2 comma 1 goes to 1 comma pi over 2. Okay? Again, not a straight line. And now we have to decide, do we curve this way or the other way?
Over the top.
So should it be slowing down as it gets to this point, or should it be increasing? Good. Okay, and here's how I always remember it. If you know that these graphs should be stuck between negative 1 and 1, it's the same idea over here, right? So if it's going to be stuck between negative 1 and 1, you can kind of see what it needs to do as it gets there. Does that make sense? It wouldn't make sense to go that way, because then that means it would keep going, which for the inverse it wouldn't. Okay? So the domain here is negative 1 to 1, and the range is negative pi over 2 to pi over 2. So now you understand what your calculator does. Remember, you don't have to write this down, but if we have sine x equals 4, I mean, we know that that's impossible, right? But if you have to solve this, what do you type in the calculator if you pretended that there was an answer? You do inverse sine of 4. But look at what the domain for inverse sine is. Negative 1 to 1. Your calculator knows that unless you type in a value from negative 1 to 1, you can't solve this problem. Okay? And you may have noticed that when you're doing inverse sine, your calculator always spits out an answer in quadrant 1 or quadrant 4 if it's an inverse sine. Have you guys seen that? No one's seen that. Okay. Patrick has seen that.
Oh, no, I have a question.
Oh, okay. What's your question?
This is kind of off topic, but related to this.
Yep.
So, like the calculator problems, before there was calculators, was there a way to do it, like a long way? Or no?
They had actual like tables, like you'd have to look in a book, and they had pages of tables like numeric values where people actually had already worked out approximations by hand. So then it's, instead of using the calculator, it just say, okay, my angle is between this and this. Let's look it up, and it's between these two, and that's how they do it. But new century. Okay. All right. So let me illustrate a point here. Okay. What are you looking for here? What is x? Don't think function. Just what does this represent inside of sine?
Value.
What kind of value? Let's be more general. An angle. Okay? Does everybody agree or see that for all of these over here, you're looking for an angle that has a sine of 1/2, sine of 1, sine of... Does that make sense? This over here on the right side says the same thing. Do you guys see the connection there? Whenever you do the inverse of a value, your calculator spits out an angle, right? Does that make sense? So, and you can actually see it. Let's say I did not know how to solve this equation. Well, you would have to do the inverse sine of both sides, right? You guys see what I'm talking about? Like if I did not know how to solve this equation, I would apply the inverse sine on both sides. So then on the left we get x, and on the right we get inverse sine of 1/2. So you see these are one and the same. This equation and that equation represent the same x value. So for all of these questions, okay, here's what you need to remember. If it's something inside of sine, we're looking for an angle. Okay? If you're doing the inverse sine of something, you're still looking for an angle. Good news is you guys already know all of these. The bad news is we're going to have to be very specific now as how we write our answers because we're using restricted sine and inverse sine. Which means, if you look at our angles, where are our angles from negative pi over 2 to pi over 2 only? Does that make sense? So you are not going to tell me, you know how before we'd have to go all the way around and say, well, I could do 130 and I could do 2 whatever and go all the way around the unit circle? There's only one answer for all these questions. Okay? And it's either going to be in quadrant 1 or in quadrant 4. Okay? So let's do this first one. If we're using restricted sine, meaning we're not listing a whole bunch of answers, we're just spitting out the one answer that there is, what angle has a sine of 1/2? But if, let's do radians. Pi over 6. Easy. If this is pi over 6, then so is this guy. Because it means the same thing, right? Pi over 2 for this one. You guys agree? So this would be also pi over 2. This means tell me what angle has a sine of 1, and so does this. Tell me what angle has a sine of 1, right? This means tell me what angle has a sine of negative root 2 over 2. Say that louder, right? Negative pi over 4. Because we are with the restricted sign, these are the only possible values that we can spit out as answers for angles. So if we think visually, we can either rotate upwards, but we cut off at pi over 2, or we can rotate backwards, and we cut it off at negative pi over 2. Does that make sense? What's that? Okay. So yes, 3 pi over 4, I heard someone say that. Actually, not 3 pi, 5 pi over 4 would be an angle that has this sign, but not with these restrictions that were between negative pi over 2 and pi over 2. Same with 7 pi over 4. Yeah.
7 pi over 4 is
Too big, because to get to 7 pi over 4, you'd have to go all the way around, right? And I can't do that. I can't go past pi over 2, and I can't go past negative pi over 2. Okay? Where is the sign 0?
Negative. No, just kidding.
It's already 0 when we start, right? Okay. Last note on this page. This is important. You'll hear me say this a lot. Okay? Inverse sine, same exact thing as arc sine. Okay? If you see the word arc in front of sine, cosine, and tangent, that just means inverse for all those. Okay? Different way of saying it, it's actually smoother off the tongue. Less syllables to say. Okay? And this notation was also used because some people look at that when they first learn it and think, oh, well, that's just 1 over sine, right? But we know it's not. Because what's 1 over sine actually? Cosecant, right? Not inverses, right? This is not the same thing. This means inverse sine. So a lot of times to avoid the confusion, math people like to say arc sine so that people don't think it's the reciprocal of sine. Okay? All right, next page. Same theme. I think you guys are hopefully going to start to see what we're doing here. Oh, good. I still got time. So, from negative 2 pi to 2 pi, if I'm at 0, where does cosine start? 1. Very good. So it goes down and then back up. Same thing this way. So it looks roughly something like that. If we look at the whole picture for cosine, if we look at the whole thing, is it 1 to 1? So will it have an inverse currently? Let's do the same thing we did before. Where could I look so that it covers every value we need from negative 1 to 1? Okay, so I hear negative pi to pi, and yes, that's one option.
Pi to 2 pi.
I'm sorry, negative pi to 0 is what I heard. What's the other one?
Pi to 2
Pi to 2 pi.
pi. Negative 2
How about 0 to pi? If we're trying to keep things as easy as possible, 0 is usually a good number to use, right? And we want to go positive rather than negative. Doesn't matter that we're going down as opposed to up, okay? But as long as we hit everything from 1 to negative 1 in this little box, then we're good. So this picture right here is the restricted cosine. So let's graph that very carefully. So the restricted cosine graph starts at 1, goes to 0 at pi over 2, and then finishes the entire range at pi because it ends at negative 1. And again, we have to draw some curves here. It's not just straight through. Okay? As I go this way, what should I start to do at 1? It's got to start to come around, right? Because it's going to come back down. So it's going to look something like that, and then this will do the same thing. Okay? You guys see how I'm getting that picture? So for the inverse, we flip all the points, except we're okay. So instead of y going from negative 1 to 1, now x will go from negative 1 to 1. And then y will go 0, pi over 2, pi. Okay, so this one's going to be a little bit more tricky. What's wrong? Are you sure? Okay, then. I'm going to assume that your cry for help was not a cry for help at all. Okay. Let's start with this point. 0, comma 1, if we're flipping it around and doing the inverse of that, would become 1, comma 0. So here's this point. I should be using red, sorry. Pi over 2, comma 0 becomes 0, pi over 2, and then pi, comma, negative 1 becomes negative 1, comma, pi. Erica, could you close the door real quick?
What?
Okay. So then, if we connect the dots, again, not with the straight line, hopefully you're starting to see the pattern here. It should look roughly something like that. Because remember, we're stuck between negative 1 to 1, so it should look like that. It's just a small picture of that. Okay? So the domain, 0 to pi, range, negative 1 to 1. That's for the restricted. The inverse will just flip around. And now I want to call attention, before we finish this page, I want to call attention to where these angles are. Instead of from negative pi over 2 to pi over 2, we're from 0 to pi, which means what quadrants should we be thinking about? So we want anything in the first quadrant or anything in the second quadrant, and that will be our answer for these questions down here. Okay? So cosine, positive 1/2. When does that happen? Pi over 3, which means that this will be the same. This is the same theme as last page. Two different ways of saying I'm looking for an angle that has a cosine of 1/2. Two different ways of saying I'm looking for an angle that has a cosine of 1. So as we go from 0 to pi, where is the cosine 1?
Oh, the 0.
Yeah, it's already 1, right? If I start at 0, the x-coordinate is 1. Negative root 2 over 2. Well, what quadrant's that going to have to be? Second. What angle is that? 3 pi over 4 is correct. Well, because now we're between 0 and pi, right? So we're going just the normal way, but we're stopping at pi. Cosine of 0, where? Right here at pi over 2. Okay, two different ways of saying the same thing. Here's what I want you to get down. We'll finish this page tomorrow, but here's what I do want you to write. For the restricted tangent function, the domain is going to be negative pi over 2 to pi over 2. The range will be negative infinity to infinity.
No brackets?
No brackets. And if you remember the tangent graph, remember we have asymptotes? So that's why these are not in brackets. We'll do this tomorrow.
So I got this right here.
Just write down the domain and ranges so that when you're doing the homework, you at least know what we're talking about. All right. Homework is day 8. We'll finish 9-5 tomorrow.